This is a little review about how to write the electron configurations and fill in the orbital diagram for different elements. It goes like this. First of all, you need a pair of arrows. Probably will have those on the test for you, but in case I don't, what you would do is go to the Insert menu, which is right here, come down to Special Characters, which is somewhere right there it is. Then hit the up arrow and the down arrow, and that puts in the arrows like this. So right here, I'll show you again. Once again, you hit the up arrow and the down arrow. So the up arrow's here and the down arrow's here. You only need to do that once, and then you'll use those arrows to fill in the boxes. So the element I was going to do is lead. I'm going to copy those two arrows, take you over here to the periodic table. We look at lead to see how many electrons it actually has. You remember that lead is a kind of a big element. This is taking a while to load in, but it'll come in a minute, I think. There it is. Okay, so lead right here has 82 electrons. So we have to put in 82 arrows. So I'm just going to start putting them in. There's 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30, 32, 34, 36, 38, 40, 42, 44, 46, 48, 50, 52, 54, 56, 58, 60, 68, 70, 72, 74. Let's see if I can make that look a little better. So 2, 4, 6, 8, 10, 12. Should have 2 more in here. Okay, so now I'm at the end of 4F. Then we're going to go ahead and fill in the 5D. Recount here. This one was 56 right here. So 58, 60, 62, 64, 66, 68, 70. We're going to 82. So 74, 76, 78. Wait a minute, I miscounted. So this 6S is 56. And then 58, 60, 62, 64, 66, 68, 70. 72, 74, 76, 78, 80. And we're going to 82. So now we're over here. Now I haven't said anything about it yet, but I was cheating all the way up here because I was putting them in as pairs. So technically, when you put these electrons in, I'm going to delete that pair out. Technically, you should have a single here, a single here, a single here, a single here, a single here. Then you come back and double, 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 double. I pasted in pairs because it's quicker, but here we are in the last sublevel and you have to put in single arrows. So one here and one here. Now we have 82 arrows in our picture. The electron configuration then would be written like this. I'm going to start over here because it's going to be a long one. So you have 1s, which has 2 electrons in it. That's this guy right here. Then the 2s has 2 electrons in it right here. Then the 2p has 6 electrons in it. That's 2, 4, 6. I'm going to go a little faster, but I'm trying to show you where these come from. So 3s holds 2. 3p is going to have 6 in it. And then 4s2. And after 4s2 is 3d10. After 3d comes 4p, which has 6 in it. After 4p comes 5s with 2. After 5s comes 4d, which has 10. After 4d comes 5p, which has 6. After 5p is 6s, which has 2. After 6s, we had 4f, which had 14. After 4f, we had 5d, which had 10. And then after 5d was 6p, which only had 2 because we ran out of electrons. So we'll count these up and double check. So I've got 2, 4. My 6 didn't get transposed in there. 6 was supposed to be there. So 2 plus 2. Actually, let's superscript them so we can tell them apart better. So to superscript these, you highlight them. To do that, you use the control key on the Chromebooks. If you're on an Apple computer, it's the command key. If you're on a PC, I'm not sure what it is, but it's one of those keys down in the lower left-hand corner. Just hold that down and drag over the numbers that you want to use using your trackpad, or I'm using a mouse because I have a wired mouse attached. So once again, all I'm doing is highlighting the numbers that I want, and then we hit a control period, and it makes them all superscript all at the same time. All right, so now we're going to add them up and make sure we hit 82. Make it a little bigger so we can see it better. So 2 plus 2 is 4, plus 6 is 10, 12, 18, 20, 30, 36, 38, 48, 54, 56, 56 and 14 is 70, and 10 is 80, and 2 is 82. There you go. That's the configuration. Now we want to do the outer shell. The outer shell is the part of this configuration down here that has the highest value of n, or the highest coefficient. So let's change this to red. I'll point that out. Right there's one of them, and here's the other one. So these are the two with the highest coefficients. They're the 6s. So what we're going to do is copy this, and then we'll paste it in right here where it says outer configuration. Now again, part of that doesn't belong, because what is the part of this that doesn't have the highest coefficient? It's this 4F and the 5D. So I'm going to delete those out of there. And that is the outer shell configuration. I want you to notice that there are 2 electrons here and 2 electrons here. There are 4 electrons in the outer shell. It's not coincidence that lead is in the 1, 2, 3, 4th column on the periodic table, the 4th tall column. Right there it is. It's put there because it has 4 electrons in its outer configuration, 2 and 2. All right, the noble gas configuration. That means it's a shorthand, so you don't have to write all of this stuff down here. So go back to the periodic table, find lead. To write the noble gas configuration, you move up 1 row on the periodic table and then go to the far right end of it, to that element right there, xenon. If we were trying to write the configuration for tin, you'd go up 1 over here, krypton. If you're doing germanium, you go up over to argon. But this is lead, so we're going to up over to xenon, and xenon has 54 electrons. Okay, so I'm going to type in brackets right here, Xe. And Xe stands for 54 electrons. So down here, if you add up all these numbers I'm highlighting, stop right there, that will be 54 electrons. So instead of writing all of that stuff that I just had highlighted, get my finger on the key here. So instead of writing all of this, I can just write that. Then you just put in what was left over that wasn't included in xenon, so you copy that, paste it in, and then you have the noble gas configuration. Looks like that. All right, that's how you do the electron configuration sheets.